Session is being recorded. Nestor Montana, I see you want to ask me something, no? I don't hear you. If my audio is working, checking if my audio. I don't hear you. Montana, Nestor, I don't hear you. No voice. Okay, student. So what we will do today? Today, no, I don't need to show this. Okay. Content in Blackboard. In Blackboard content, you see, you have to find folder lecture 14, work, energy and power, chapter 7. Let me go to inside this folder, lecture 14, work, energy and power. First you see gravity problems. So on the top, something which have relationship with previous materials, gravity problems. Okay. After this, you see the chapters. You see chapters of our textbooks, and so today you have to focus to chapter 7. Chapter 7. Okay. Then you see in chapter 7, first you see homeworks for self-examination. For self-examination. I will not collect these solutions. After this, you see web link to section of chapter 7. And then you see our video, what we will watch. Mostly Professor Dave. Then video another type. And on the bottom you see lecture 14 test work. Today we will work a little bit different than before. First we will watch first video, and then after first video, all of you will start to do first problem of this test, lecture 14 test work. It will be our first step. First we will watch video, work and energy. When we'll finish, a little bit maybe discuss. All you have to go to lecture 14, test work. What we will do after this, I will explain. So step by step. Let me start first step. If you don't have questions, to gravity problem, we will back to gravity problem, but first we will start new material. Gravity problems. Okay, so now I see how many students. I see students, 12 students, no? Is a third of our list of students, no, but we will start to watch. So, work and energy.
Professor Dave here. Let's learn about work and energy.
He knows a lot about the science stuff. Professor Dave explains.
Just like force, the words work and energy have a variety of connotations in common language. When we say work, sometimes we mean exercise. Other times we mean a place we go every day and do something to earn money. Energy is even more convoluted. We might say that today we have no energy, meaning we feel tired. Or we might use the term in a completely metaphorical way, saying that a person or a location has good energy. But once again, in physics, these words mean something very specific. And if we are to learn science, we must allow the rigorous definitions to replace the colloquial connotations. Work is defined as action done on an object whereby an applied force causes a displacement of that object. A basic example would involve pushing a box 10 meters across the floor. Work is equal to the magnitude of the applied force times the displacement of the object. So it has units of force times distance. If you push with a constant force of 100 newtons over the 10-meter distance, you would do 1,000 newton meters of work, which are equivalent to another SI unit called joules. This means that work can only be done when displacement occurs. If you push a brick wall with the same force for the same amount of time as the box, you may get very tired, but technically you have done zero work. In addition, only the components of the applied force that are parallel to the displacement are considered to be contributing to work. If you push the box with your arms parallel to the floor, all of your effort contributes to work done on the box. But if you are pushing at a downward angle, only the x component contributes to work, while the y component does not. In such a scenario, instead of using W equals Fd, we could calculate the work done on the box using W equals Fd cosine theta, as this will give us the portion of the applied force that is operating in the horizontal direction. If theta is 0, meaning the applied force is horizontal, cosine theta will be equal to 1, leaving us with W equals Fd. And if you were to push straight down on the box, theta will be 90 and cosine theta will be 0, meaning no work is done on the box and it will not move. Any angle in between and there will be some motion. We must bear in mind that work is a scalar and it can be positive or negative. Work will have a positive value when the applied force is in the same direction as the object's motion, like when pushing the box. And work will have a negative value if the applied force is in the direction opposite the object's motion, like if your baby brother pushes the box the other way, but without enough force to stop it from moving forward. The sign on work is very important because it tells us if the speed of an object will increase or decrease as a result of applying the work. Energy, another elusive term, is quite simply the capacity to do work, and this is summarized in the work-energy theorem. This states that when work is done on an object, there will be a change in that object's kinetic energy, which is the energy of motion. This also means that an object in motion is able to do work on another object. The work-energy theorem brings together concepts from Newton's laws and kinematics to describe motion in a way that we will examine further in the next clip. For now, we must simply purge ourselves of any prior connotations of the word energy and understand that it merely describes a property of an object or system that can be transferred into another object or system, often in the form of work. There are different kinds of energy, including kinetic and potential energies, thermal energy, chemical energy, and more, and we will discuss all of these when the time comes. Once again, the SI unit for energy is the joule, which is defined as a Newton meter, even though energy is not always transferred in the form of work. But our understanding of energy will grow as we examine the various types of energy. So let's move on to that part of the course. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email.
Okay, students. So in this video, you saw 3 equations. Okay, maybe I will go back to equations.
Professor Dave here. Let's learn about work and energy.
First
Force
equation
of
is
100.
work equal force times distance. Work is a scalar. Force is a vector, have direction. D is a vector, have direction. Just now in this form, this equation correct only for one-dimensional motion. So force has the same direction like displacement. And if it has the same direction like displacement, force times displacement equal work, and work is a positive. In another situation, force is a parallel to displacement, but opposite to displacement. So in this situation, work will be negative. Okay. If we have already two-dimensional or three-dimensional space, so for this situation, we can write another by another way. Work equal F, the magnitude of force, times D is the magnitude of displacement, just how big, times cosine angle between direction of force and direction of displacement. After this, you see only more one equation. Work net equal delta Ke. No, Ke is a kinetic energy. This delta, it means change of kinetic energy. Net work net, it means work it's produce net force, the sum of all forces. So if sum of not forces is not zero, so they produce motion of object. No, we not produce acceleration, but in the same time produce like a motion of object, and kinetic energy of this object will be changed. It will be increases if work is a positive. Okay, what we know this equation, no sense, and now let me go to bottom of this folder, and you have to start in the bottom of this folder. You have to start what you have on bottom of this folder. At the bottom of the folder, you will find lecture 14 test work. Start this test work and just now focus only on first question. So if you start lecture 14 test work, first begin, you will see many equations. Choose the correct relationship on the dimensional motion between the work done, force F acting on object and the displacement D the object undergoes. So this like result of main equation what you know already for one-dimensional motion, work equal F times D, force times displacement. Now, of course, mathematical expression give relationship between parameters, but we can rewrite by another way of this equation, and it will be the same parameters. So now you can find correct like expressions which give correct relationship between FD and work, and not correct according to your algebra knowledge. Okay, student, let's start. If we work all now, we have to work lecture 14, test, work. Lecture 14, test, work. Just now in class, I see 14 students. So now I want to see that all 14 students start to work with this test. I see that you work in my grade center, and I will check your results. No? Now I see only Montana, Nesser start to work. Where another students? Students run. Да. Okay, student. Again, I repeat. Okay, I see your messages. Not about main what I want to do with you. If you have access to Blackboard, and because you have access to me, you have access to Blackboard. You have to start test. Test, you see test, and don't do all tests. Not necessary. At least do only first question. Only first question. Choice. Choice correct relationships, correct formulas. Main formula W equal F times D. Yes. Can you go over question 4? Montana, okay. Step by step. No, what question 4? For me, just now important that I want to see all students. What question? No, your question 4. Okay. Another student will start. We check your result. Okay. Question 1, correct. Select answers, correct answers. What, Nesser, be careful. In question 1, we have not one selection. We have many selections. Try to find all correct. Not only W equal F times D. Is easy. But there is another correct relationships. The same in question 2. The same, question 3 a little bit more complicated because already this you have to use vector algebra. But in any case, in question 3, we have many correct relationship and many not correct relationship. Okay. So, Nesser, go back to first question. Find all correct relationship between work, force, and displacement for one-dimensional motion. For one-dimensional motion, we don't have angles, and force and displacement can be or positive or negative. So if both are positive, work is a positive. It means both have the same direction. Is one positive, another negative, so work is negative. And when force and displacement have opposite direction. No, and if both have minus minus to negative direction, but in any case minus times minus gives a plus. So in any case, work is a positive. Okay, but find all. You have to find all correct, and don't make mistake. Don't take not correct. Two students. Student, where are you? Only two, all of you.
Excuse me, we're only doing the one question, right?
First question.
That's it?
First question. That's it. Only
Okay.
first question. But correctly. Only first question, but correctly. That's all. 14 students I see now in our session. So now all 14 students have to solve. Doesn't matter, correct or not. Try to do correctly. Show your algebra knowledge, because you have to find, according to initial equation, F equal mg, what another equation describe the same relationship, correct relationship between work, force, and displacement. Okay, now I see. Students working. Not necessary to answer all questions. Altman Rachel. Only first question, that's all. And don't submit. I will check your answers. Так. Don't submit. Only do answer, that's all. No, what I see, Ilya Filipenko. You are good for first question. Yeah, good. То есть вот. Okay, some another student. Kennedy Cerisier. I don't see your answer. Adama Ba, you made mistake. Check again your answers. No, okay, main result. What can say? No, 1, 2, 3, 4, 5, 6, 7, 8. No, I see. So maybe I cannot check all of you, but many of you already work with this. And now together we will check some answer. Okay, what answer for first question? Now I have to show you. Okay, great. So for example, let me check solution of Maxim. Let me check his solution. Okay. And what we see, okay, Maxim made correct solution, and now I will show to all students. So So now you see, student. Only because W equal F times D. According to algebra, D displacement can be found like work over force. And force can be found как work over D. No, or work equal F times D. What we have one equation really give three equation, correct equation. Or all another relationship what you see in choice answers are not correct. Just only three are correct. Okay, we made this. No, only don't confuse. Numeration of equation you have different. This most important. Work equal F times D, correct, or D equal work divided by force, or force equal work divided by D. Okay, so now we found correct relationship for one-dimensional motion. Second equation what we learned in this video is already for two or three-dimensional motion. When we write work equal magnitude of F times magnitude of D times cosine angle between direction F and direction D. So go to second question. Now for second question of this test, again you have to find correct relationships. No. Okay. And I see somebody already made correctly. Yes. So somebody show knowledge of algebra. Really the knowledge of algebra. So I see you are working. Many of you working. Yes. Now let's time to show what is a correct answer for question number 2. So now I will check some student. Question 1, question 2. Okay. So now I will show you some example. Okay. Application screen. Great test. What you see some answer. So correct answer. No, first, because work W equal F times D times cosine theta, so we can rewrite this equation to put along on the right F D cosine theta and theta. And all of this equation exists in list. So how many correct answers? Is a 1, 2, 3, 4, 5. First initial form, W equal F times D times cosine theta. And then solution of this equation for F, solution of this equation for D, solution of this equation for cosine theta. And of course, because we know cosine theta, we can find theta. So theta is the arc cosine of ratio work over F times D. So you see correct answer, and what student, what I show you now answers, lost one solution. To lost, what's lost? Lost angle theta equal arc cosine, or cosine is the power minus 1, is I don't know how to call this, reverse cosine maybe, I don't know. I know this like arc cosine from ratio work over F times D, where F is a magnitude of force, it means absolute value, how big, D is absolute value of displacement, W work, no, and theta is a angle between direction of force and direction of displacement. Okay, now time to go to question number 3. So in question number 3, I have to explain you a little bit because maybe your knowledge of mathematics not enough. No, we will check some answers. No, what the same student. Question 3. What? So first, what you have to know. Some in scientific textbooks, in scientific articles, if you see some letter with an error on the top, it means this is a vector. So vector mostly in 3-dimensional space, maybe in 2-dimensional space, but it's what? It have magnitude, it how big, and have direction. If you see on the right and on the left like a vertical line, it means absolute value or magnitude of vector. So it means we don't focus already to direction, only how big is this vector. What does mean vector? It means it's because it's in general in 3-dimensional space, vector it's like arrow have component X, component Y, component Z. What we can write fx is a component of vector fx, fy component of vector fy, and fz component of vector fz. The three, really, one vector is a three numbers. Component x, one number, component y, another number, component z is another number. The same for displacement. So if you see d with the arrow, it means vector, d with the arrow with the vertical lines left and right, it means absolute value, it means magnitude. And of course, if we know vector d, it means we have to know component x, component y, component z, what we call dx, dy, and dz. Okay. And for vector operation, for vector operation, we have two products, dot product and cross product. Result of dot product between two vectors is scalar. But now maybe some of you know what does it mean, dot product. Maybe some maybe not. But now I cannot. I'm not ready to show you exactly what does it mean, dot product. But if you know component of vector, so one method to calculate dot product, for example, f dot product vector f dot vector d. So result is a fx times dx plus fy times dy plus fz times dz. No, of course, I have to show, not only to say. Maybe you cannot catch this, no? But what? Now you know in which direction you have to learn. You have to go to math book about vectors, no, or many physics books have the same. So you have to know definition of dot product. No, and you have to know another method of dot product through angle between two vectors, f and d. It's exactly dot product f dot d. Another way how to calculate is a magnitude of f times magnitude of d times cosine angle between these two vectors. Exactly is a definition of work. So work is a dot product between vector f and vector d, dot product. And we have two methods to describe this dot product, through cosine and magnitudes of vector f and d, or through component x, y, and z, both vectors. No, a cross product is already another situation. Someday maybe I will explain you what does mean cross product, but just now it doesn't have relationship to work. Okay, no, and what we can find, no, what student make mistake. What kind of mistake? No, first let me check correct answers. What? We have the three correct answers. First correct answer is exactly, no, definition. In these terms, work equal dot product between vector f and vector d. And you see f equal f vector d vector. No, just now is this equation 1. The same dot product, but already when we write through component, you see w equal fx dx plus fy dy plus fz dz. The second equation. No, and again, and because more than equation don't exist here, work equal magnitude f times magnitude d times cosine theta, we can use equation previous with number 5 here and magnitude of vector f and d to find cosine. Because magnitude f times magnitude d times cosine theta equal fx dx plus fy dy plus fz dz. If we left and right part will divide by magnitude f times magnitude d, we will find equation for cosine theta. And you see cosine theta equal, and you see what the last equation with the number 6. What are not correct? What you see, student made not correct choice. What? Work equal magnitude f times magnitude d. Why is not correct? Because work really equal, if you will start with the magnitude f times magnitude d times cosine angle between direction f and direction d. So answer number 3 is not correct. Okay, and in this choice 8 not correct, because in choice X we have already not dot product, we have cross product. Cross product is another history. So it's not correct. Okay, no, it's one student. Let me check some another student solution. Okay. No, for example, okay. Later I will check. No, I use random student. Bakir Shoshana. Let me check yours. No, first, we already discussed question 1. Correct question 1. Correct answer. W equal FD. First correct answer. Second correct answer. F equal W divided by D. And last correct answer. D equal W divided by F. So we have 3 correct relationship. Another relationship are not correct. Question 2. Question 2. I don't see knowledge of algebra. But in question 2 we have 1, 2, 3, 4, 5 correct answers. First, like from definition, no, this is by number 6. Work equal F times D times cosine theta. Ascend solution for F. Force is a work divided by D cosine theta. Or D equal work divided by F cosine theta. Or cosine theta equal work divided by F times D. And finally, angle equal R cosine of from ratio work over F times D. 1, 2, 3, 4, 5. 5 correct. Another not correct. Okay, let me check some another student. Maxim. Tersincev Maxim. Let me check yours. Ну вот, Tersincev Maxim, I see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What? All answers correct. This question 2 correct. And question 3. Let me check question 3. And question 3 correct. Yes. What? Now we see question 3. This what? Correct. Work equal by component fx dx plus fy dy plus fz dz. Or by another way, but it's the same, work equal dot product vector f times d, dot product. and we can find cosine angle. If we will find that product, no, that now is in form of component fx dx plus fy dy plus fz dz divided by magnitude f times magnitude d. Okay, students, so you know correct answer for question 1, 2, 3. Now go to question 4. Question 4, no, you have already calculated. Question 4. What you see diagram. In this diagram, you see vector F, force, and vector D, displacement. And you have to find work which produces this force when it's acting to some object, and this object make displacement D. So you have to remember formula. What is work? Is a magnitude of F times magnitude of D times angle between F and D. Angle between is a key word. In this picture, you see two vectors, vector theta 1 and theta 2. Are this vector between F and D? No. These vectors are not between F and D. How to find vector between F and D? How to find angle between F and D? Okay, student, you have to think about this. So, solution is a F times D magnitude, F times magnitude D, times cosine angle between F and D. Okay, let me check what now, Maxim, you have mistake. Repeat again. Okay, some another student. Lean, for example. Let me check lean. Lean, not given. Not given. What do you do, lean? Why you don't work? We already know solution for question 1, question 2, question 3. You still didn't write the solution. Answer solutions. Okay, some another student. Okay, some student. No, let me check. Okay. If I will. Altman Rachel. Let me check your attempt. Second attempt. Altman Rachel. No, Altman Rachel. We already know for question 1 correct answer. We know correct answer for question 2. Correct your answers. We know correct answer for question 3. Correct your answer. Now we work with the question 4. But before question 4, correct your answer for answer 1, question 2, and question 3. Okay. Somebody asked me something. What question? Nesser. Yes, now we'll check yours, Nesser. Yeah. Okay. Nesser, Montana. Okay, and what we see? Question 1. You write correct. You made selected answer correct. Question 2. Correct 2. Question 3. Correct. And now you work on question 4. Question 4 and question 4 is not correct. Again, focus to my words. What is a work? Is a magnitude of F, that's magnitude of D, times cosine of angle between F and D. There is in this problem you don't have angle between F and D. You have to find. You know vector theta 1 between D and X. And you know vector theta 2 between Y and F. Now you have to, I don't give how to find vector between F and D. My guess it's easy to find. No? Okay, some another random student. For example, Brian. Brian, make correction. Question 1. Your choice is not correct. Correct your choice for question 2. You have wrong answer. You have wrong answer for question 3 too. And question 4 is not correct. Okay, student. I help you for this. Vector, the total angle between x-axis and y-axis is 90 degrees. So, and 90 degree equal angle theta 1 plus angle theta 2 plus angle between vector f and d. So to find angle between f and d, what you have to do? 90 minus theta 1 minus theta 2. It will be vector between f and d. So what is the work? Is a f, you have f, times d, you have d, times cosine from vector 90 minus vector 1 minus vector theta 2. Exactly what will be your answer depends on what kind of number you have, because all you have different numbers. So just now, what for this problem? No, what I will help. I will show you how to calculate. What exactly for this data? What you have f, d, angle 1, angle 2. Okay, how to calculate? I teach you. No, there is a many ways. I prefer to do calculation using or Google Sheets or Google Search. Now I will show you how to do using Google Search. So I go to Google Search. Now I will have to change. Okay, now I will change my screen and I will show how I use Google Search. Okay, Google Translate, Google new tab, maybe it's new tab. Yes, maybe new tab. Okay, you see in new tab, exactly open in Google Search. So first I made copy to remember numbers, and now I do paste, Control V. Okay, to have numbers. So I see F. I have F, 4.77 N newtons, times D, 6.45 M meters, times cosine what? 90 deg mean degrees minus 36 deg is mean degrees and minus 17 deg is mean degrees. What I have formula like this. Now I have formula 4.77 n times 6.45 m times cosine 90 deg minus 36 deg minus 17 deg. Deg it's mean degrees. My guess, my hope, Google search will understand me. Just in case I copy this and enter. Okay, and I have answer 24.57 joules. See, it gives me already incorrect units. Joules. Joules is unit to work or energy. Okay, now I have to think how I have to submit this. So I have to read again problem, what they write, input the numerical part of your result using a regular notation with 3 significant figures. So 3, this regular notation, I don't need to use scientific notation. So from my 24.5, 3 significant figures is 24.5, but I can change 5 to 6 because next is a 7. So my answer will be 24.6. Now I will check. Answer, and exactly 24.6 is the correct answer. So now you know how to do what, how to use, why Google search is useful, because it helps us check not only operation, mathematical operation, it gives us possibility to work with the units and check how we correct use unit. And you see exactly what we have in the result in joules. Joules is a unit to measure work or energy. Okay, now I will check. So I go back, and now I will check again your work, students. Did you reach a good result or not? What this you see again this problem for one student. So Brian, you already know correct answer. Write correct answer for this problem. Another student. Let me check another students. For example, no. MD Faisal, some random student. Let me check his solutions. Faisal, you still have not correct question 1. Your selected answer only 1. There is a 3 correct answers. Question 2 look like correct. You may choose all of them correct. And question 3, okay, you made one mistake. W equal absolute value F times absolute value D is not correct, because correct, we have to add more cosine theta. So first is not correct. But you skip something. You skip? What? W equal F dot product D. You skip this correct. And question 4, oh, still, your answer is not correct. Question 4. Recalculate. Okay, another student. Chan-Chi. Oh, Chan-Chi, that doesn't work today. What happened, Chan? We don't have Chan-Chi today. Okay, student who, what next? Let's check next your results. Okay, question 1 correct. Question 2 look like correct. Question 3 look like correct. Question 4, oh, correct. Question 4 correct, so good. So we have correct answers. No, and question 4, next question 5. I think question 5 is easy, because in question 5 you exactly have angle between F and D, but why you have mistake? You have F, you have D, you have angle. Easy, F times D times cosine angle. What happened? Why we have not correct answer? Nesser, what you make not correctly in question 5? You don't know? Can you check what Nesser? What I this correct 5? Working on it now. What 5? Just 5 is what? No. Okay, I will show to all students now. What again? What we work with the what with this data? We know F, D, and angle, and we check. Yes, is the same. Is exactly angle between F and D. So to find work, we have to use cosine of this angle. So what I do? I copy this. Copy. Go to Google search. Okay, now I will show you what I have in Google search. Okay, Google search. This. So now you will see. First, I paste to Google search my given data. To what reason? To write correctly. What I have, F equals something. I don't need F equals something. I have only F. F magnitude times D magnitude times cosine, sine what? 67, and I write degrees, mean degree, because Google search don't understand sine degree. What you see, okay, if you don't see, I have to increase. What? See my expression. Force, and I write exactly right, N, it means Newton, unit of measurement, time displacement, and I write number together with the M, times cosine 67 degrees. Okay. I have to click enter. And I have answer. 14.00 and so joules. Okay. If I have to write in regular notation, 3 significant figures, so my answer have to be 14.0. 14.0. Don't forget 0.0. Let me check. 14.0. Yes, 14.0 is correct answer. 14.0 is a for Montana, Nessa Montana. Your correct answer is a 14.0, and maybe you understood me. Yes? 14.0. Okay. Question 6. Question 6. Again, question 6 on calculation. So, what we know in question 6? So, all you students have the same question, but only you have different numbers. I will read this example. So what we know this, question 6. Force F, and we have number in Newton, acting on the object that is displaced on distance d, and you have number. Produced work, and you see W, you see some work. Find the angle in degrees between the direction of the force and the direction of the displacement. Input the numerical part of your result using regular notation with 3 significant figures. So what kind of equation we have to use? We have this equation in some our previous, maybe we don't have. Not exactly. No, really. What? Maybe where we have what? We have this equation. What in question 2? This with the number 6, angle equal arc cosine from ratio work over product magnitude F times magnitude D. Why? No, because of what main equation, work equal F times D times cosine theta. So we can find first cosine theta equal work over F times D. And then to find theta, we have to take arc cosine from ratio work over F times D. So only question how you will calculate, what you will use to calculate. No, I will try to show, no, what? Student calculate, no, correctly, but not exactly, but maybe system will accept this. No, I will show you how I will try to calculate. I didn't do this, but I will try now using, again, I will use now Google search. So I have to calculate what from ratio. I have F, D, and work. I copy this to go to Google search. Now I will show in Google search what I will do. So I have to change to we are located in Google search exactly. Okay, so in Google search now what I first paste all my data, Control V, what I have F, D, and work. So what I have to do? Work, this work. Divided by product F times D so this ratio, and this ratio I have to use in function, no, there is a different name, I call this arc cos. No, I will try like this, I don't know exactly. Arc cos, maybe it work, maybe not, I will check. Arc cos, or maybe A cos, maybe. Copy and enter. Not much any document. So no. Let me try A cos. A cos. Or what? And it gives me now. You see, A cos is working. System understands what I want and give me result in radians. Now I have to check what kind of result I have to have. I have to have, according to problem, what input the numerical part of your result using regular notation, tracing figures, find the angle, find the angle in degrees. I have to find angle in degrees. But system, Google search, give me in radians. So what I have to say? I have to say in degrees. Degrees. In degrees. Enter. And it gives me in degrees. So my answer is 74.6 degrees. So regular notation, 3 significant figures, 74.6. That I will check with the correct answer. 74.6, exactly what I have in correct answer. Okay, students, so question 6. Now I will check how you finish question 6, all students. So so you see you see my expression. If you want to use Google Sheets, how I calculate this programs, question 6. So work divided by product, force times displacement, and all is this in parentheses, and initial function, the arc cosine, A cos. And I have to add in degrees. Okay, so I will change. Greatest. Okay. exit. Now, for example, we will check. I will use random student. Random student. Not Lin Wei Feng. Let me check his result. Question 1. Student, time to correct question 1. Wei Feng Lin, what do you do? Why you didn't write correct answer for question 1? Question 2, not given. Don't sleep, students. Work. Question 3, not given. You surprise me. And of course, question 4 and question 5 not given. We have class to work, not to sleep. Okay. Filipenko Ilya. Filipenko Ilya. Let me check his answers. Question 1 look like correct. Question 2 look like correct. Yeah. Question 3 look like correct. Question 4 correct. Question 5 correct. Good, good. So another student, for example, Maxim, Tersincev Maxim. 1 good, 2 good, we already checked before, 3 good, 4 now correct, and 5 correct, and 6 correct. Yes, I didn't check 6 in previous student. 6 correct. Okay. No, I already see what. Now we go to question 7. And I already see this student, Maxim Tersincev made it correctly. Question 7. No, but now I will explain to another student. Question 7. Find the work in joules done by force acting on the object that made the displacement. Vectors of the force and displacement are given by components. So you know component x, y, and z for F for force and for D for displacement. So input the numerical part of your answer using regular notation with 3 significant figures. So what you have to use? Which kind of formula? And we have already this formula before. Is a formula what this with the number 3. Work equal fx times dx plus fy times dy plus fz times dz. No, and what? I think there is no problem to calculate this. Yes, and we have correct answer. Question 7. So now all you students, all you have to have correct question 7. Let me check. Some another student. No, I will continue check of the student question 8. Question 8 correct too. Question 9 correct too. And question 10 still not given. Okay. This last question. No, good result. Good result. Okay, so question 7. Now, student, all you, my guess, are ready to do question 7. Okay. But let now we what? Let we will continue to watch videos, students. already 7:26. No, okay, we don't have many times more. No, I want to show you videos again, but because no, we only start to work. We will watch videos now. So next video. I have to change. Next video. We only what made work and energy, Professor Dave. Now kinetic energy and potential energy.
Hey, it's Professor Dave. I want to tell you about kinetic and potential energy.
He knows a lot about the science stuff. Professor Dave explains.
We now understand a more rigorous scientific definition of the word energy as being the capacity to do work. But as we said, there are a few different kinds of energy, so we must talk about all of these varieties. First, we will discuss kinetic energy and potential energy. Kinetic energy is the energy an object possesses by virtue of its motion. If we recall Newton's second law, we know that the application of some net force will move an object with some mass at some constant acceleration. We also know that work is equal to force times distance. So if we account for the distance traveled by this object, we get that W equals FD equals MAD, or simply W equals MAD. We also know of this kinematic equation for an object experiencing constant acceleration. If we solve for AD, we get this expression, which can be plugged into the above equation for work. After some simplification, we arrive here, thus deriving the work energy theorem. This term, 1/2 mass times velocity squared, represents the kinetic energy of a system. So now we can express the work energy theorem by saying that when an external force does work on a system, the amount of work will be equal to the change in kinetic energy of the system. If W is positive, the system increases its kinetic energy, and the change will be equal to the work done on the system. If W is negative, the system decreases its kinetic energy, and this change will represent the work that is done by the system. Note the presence of mass in the kinetic energy expression. This means that if two objects with different masses are moving at the same velocity, the more massive object will necessarily have more kinetic energy. Now let's discuss potential energy, which is forever intertwined with kinetic energy. Potential energy is the energy an object possesses by virtue of its position in a field, whether that is a gravitational field, an electromagnetic field, or any other type of field. If you lift a ball up into the air, you are increasing its gravitational potential energy as it moves farther away from the ground. If you release the ball, that potential energy is converted into the kinetic energy of motion as it falls. The closer an object is to the center of gravity of the Earth, the less potential energy it has. And as you pull it up and away from the ground, it gains potential energy because it has an increasing potential to fall some distance to the ground. It may seem strange to bestow an object with more energy just by lifting it into the air, but remember that we have to eliminate our prior conceptions of the word energy in favor of more rigorous definitions. The potential energy of a compressed spring or an arrow ready to be released from a bow is where the kinetic energy of motion comes from. It is like a kind of stored energy. In this course, we will frequently be discussing gravitational potential energy for...
Okay, so what first equation? Potential energy equal mgh. M mass, g gravity acceleration, h height. Potential energy.
Objects on Earth. And for any object, this will be equal to the mass of the object in kilograms times the free fall acceleration due to gravity for the Earth times the height of the object in meters. The greater the height, the greater the potential energy, as this represents the work that can be done by gravity to produce the motion of a falling object. There is also elastic potential energy, such as with the spring or the bow and arrow, and we will discuss this later as well. For now, we just need to understand kinetic energy as the energy of motion and potential energy as the energy of location. Let's check comprehension.
Okay, we will not do this problem because we have our problems. So now you have two equations. Potential energy, mgh, and h is really the height, or y, and like any y, this axis have direction up. It can be positive, it can be negative too. So be careful. And another formula for kinetic energy. Kinetic energy, know what you see this 1/2 mv squared. Work energy theorem is a final kinetic energy minus initial kinetic energy equal work which done on this system. So if work is a positive, so energy kinetic increases. Okay, so you have to know this to do what? To answer next.
By saying that when an external force...
Okay. So we can continue work with our quiz. No, what student? I hope you will continue already without me. Work with this quiz. Today quiz. Now I want to focus you to beginning of our folder, today folder, because on beginning we have gravity problems. Okay, if I will click to problems, I will reach some page, and now on this page you will see problem. Now we will do this problem together. I hope we have time. Okay, this what now I will show to all of you, but you can do this by yourself, and you will reach some picture and text. So now you don't see in my screen. I have changed screen to show this. Okay. So now you see. So what we have to understand, how to understand this picture. I will explain shortly. We know two masses, 1 and 2, attract each other. And we have information about what is the force of attraction. For example, we read 1. Two identical masses located at a certain distance r from each other attract each other with the gravity force of 36 Newton. If you arrange 3 such masses in a straight line, maintaining the same distance r between adjunct masses, what will be the magnitude of force acting on outermost mass? So we have to focus to picture number 1. You see 1, 2, 3. We have 3 masses, the same masses, like in previous picture with the red arrow. And we know attraction force initially between two masses is 36 Newton. 36 Newton. For some reason. Now we have 3 masses like this. Question: how we will change force acting to first mass? So we add more one mass number 3, and it's located the same distance from mass 2, like 2 from 1. What will be force? Okay, student, this 36. If we have only 2 masses, now 3 masses, and what is force? It's acting to first mass. Who will? This is is not test in Blackboard. I want to see your answers in like by your voice. Who are ready to give me answer? What again? 36 Newton is the force attraction between two masses, mass 1 and mass 2. Now you have three masses and they're located in one line. Distance is the same between masses. This really we add mass number 3. What is new force acting to mass number 1? Before it was 36. What now? No, okay. My guess, Maxim Tersinsev, you are ready to answer me. Do you understand this problem? 72. Okay. Это Nessa Montana, 72. Why 72? I don't agree that 72. То есть you mean twice. Not twice. When we add more than mass, this mass located and distance from first mass. So distance between 1 and 3 twice greater than distance between 1 and 2. So 1 and 2 still attracted with the same force, 36, but we add more than mass. And so force mass 1 now attracted by mass 3 too. But distance is twice greater, because distance twice greater, it means force is less. How many times? 4 times less. So if 36 divided by 4, it will be what? 9, yes? 9. So now between masses 1 and 2, attraction force still 36, and between 1 and 3, attraction force still 9. So total force acting to 1, to first mass is 36 plus 9. So it will be 45. 45. What correct answer? 45. Okay. Picture 2. Very easy. For this configuration, 3 masses, what is force acting to middle mass? What is force acting to middle mass? Total force, net force. So we have force between 2 and 1 and 2, between 1 and 3, and between 1 and 3. And finally, we have to find what's the total force acting to, for picture 2, what is total force acting to middle mass? This mass with the number 2. Okay, who are ready to answer me this question? Maxim. My guess you will have answer. It's easy question. Easy to understand by without any equation, only use the principle of symmetry. You see, system is symmetrical. Right and left direction are equivalent. Look the same. So for this we can do conclusion. No? Nobody. Montana, Nesser, your guess. Write me. I will check your message. Only one number, that's all enough. What force acting to middle mass? Total force, net force. I don't see what you write. You write or what or you write 0. What did you write? So complicated. 0. In the middle mass, total force acting 0. Because middle mass number 2, 1 mass move number 2 to left. Mass number 3 move mass number 2 to right. And force to left equal force to right. Total force equals 0. Okay, student. Now, picture number 3. Now we have 4 masses. 1, 2, 3, 4. And what we know now in problem, we know, okay, what I have to read. This number 3, again 36 Newton between 2 masses in direction R, but now we have 4 such masses. So still question, what is total force or net force is acting to first mass acting from another 3 masses? And you see another 3 masses on the right. Mass 2 on distance R, mass 3 on distance 2R from first mass, and mass 4 on distance 3R. What conclusion? No? Who are ready, students? This main idea of this problem, we have to use properties of main gravity equation, that attraction force is reversely proportional to distance squared between masses squared. It's reversely proportional and squared. So if distance increases, so force decreases. And because squared, if distance increases twice, force decreases 4 times. If distance increases 3 times, force decreases 9 times. Force increases, distance increases 4 times, force decreases 4 squared 16 times. If distance increases 5 times, force decreases 25 times. So now we have mass 1 and in distance r the same mass, the same mass again in distance 2r, and again the same mass in distance 3r. If second mass acting to first mass with the force 36, already mass is located on distance 2r acting to first mass with the force 4 times less. So 36 divided by 4, we have 9. But next mass number 4, have distance 3 times greater. So force which applies this mass to first mass is 9 times less. So 36 divided by 9 equals 4. So what is total force acting to first mass? Is 36 plus 9 times plus 4. Do you understand, students? Okay. No, students, your official time of this session go to finish, but I'm still in connection and I'm waiting your questions or waiting what that you will ask help from me. I don't know any help. Previous problem, new problems, what you want, some explanation, what do you want? So I'm ready to work with you. At home, continue to think about this problem, gravity force. So we don't have solution for picture 4 and picture 5. In picture 4 is still 4 masses, but we have to find total force acting to second mass. And in picture 5 we have already 5 masses, and we have to find total force acting to first mass. So we will continue next time, or if you want, I will explain you now if you will ask me, if you don't want to think by yourself. And what I waiting your questions. Now I see only 6 students. How can I help you? Maxim, you have today good result. I see you have good, no, some preparation. I don't know, in math, maybe in physics too. Yeah? Maxim Tersinsev. Okay, another student, Nesser Montana. You walk in good direction. Okay, what I can say about another student, I don't know, I don't remember. I don't remember another student. I remember Adama. Okay.
Professor, I was just asking if you could check my result for the test, extra 14.
Okay, you want to see your result, yes?
Yeah.
Today test, yes?
Yes.
Okay, we will go. Okay. Okay. So, it's working slowly. So again, your name is Adama. Yes, Adama. Now
Yes.
I will find Adama. Okay. Adama. Lecture 14, test work. Attempt. Okay, Adama. I will check, do you see or not? You see, yes, you see. I see that you see. And first question, 237, correct. Question 2, 12357, 12357, correct. Question 3, 236, 236, correct. Question 4, correct. Question 5. No, small mistake because of rounding. No, maybe system will accept this. Question 6 correct. Question 7 correct. Question 8 correct. Question 9 correct. Question 10 not total choice. What? No, of course, for correct formula is a kinetic energy equal 1/2 mv squared. But the same relationship between k, m, and v show v equal root squared from 2k over m, or m equal to k over v squared, or we can write the same like k equal mv squared over 2, or we can write the same like k equal 1/2 mv squared. So total choice have to have 1, 2, 3, 4, like 4 choices. There is 4 correct choices in question 10. Do you understand?
Yes.
Okay, not bad. Generally good. Only what in question 10 you didn't find all choices, all correct choices.
Thank you.
No, you're welcome. Okay, good. If you can, I can show you another your what?
No, the other ones I'm still working on. I'm not finished yet.
You're still working.
Yeah.
No, I can show you what's if you have some answer. For example, lecture 13. What is your answer? Class quiz 1. Because I see you start already.
Yeah, but I didn't get to it yet because like the answers I didn't put them in. So
No any answer.
no,
No,
I
any
didn't
answer?
put them in yet. No.
No, okay, no, okay. Yeah, no, I see you have answer. Adama, yes, Adama. But what question 1? What is correct? What is not correct? Maybe your calculator calculate correctly, but you don't focus to condition. You have to use scientific exponential notation. I mean, you have to use e. This one, not 115. But if you want to use your number, it have to be 1.15 e2. It means 1.15 times 10 to power 2. But we don't write times 10 to power 2, we write e2. Question 1. No, question 2 not given, another not given. Okay. Do you understand? Yes. Your calculations are good, but format, what? Not good format. Okay. Another student or another question, Adama, if you want to me ask. Haidara. Al-Haji. Haidara, do you have question? Nesser, how can help you? Can you check lecture 14? Okay, yes. Is a Haidara.
Yes, Professor.
Yeah.
Yes,
Now,
yes, I have some question, but okay, go. Talk.
no, first let me start. Yes, your solution, lecture 14.
No, it's not lecture 14 though. It is like lecture 9.
Lecture 9. Okay.
Yes.
Let's go to lecture 9.
Lecture 9. Question either 3 or 4.
Lecture 9.
Yeah.
Class quiz 1.
No, 2. I believe it's gonna be 2. No, yes, one. Sorry, it's gonna be
lecture,
1.
Class quiz 1.
Yes.
Okay, so Haidara, yes?
Yes, exactly.
Haidara Al-Haji, yes? Okay, what you already submitted. I see you have 35 points. I will check
Yes.
what is not correct. What is not correct, we will check now. Okay. Note what just in case, because no, enter your answer using 3 significant figures. To focus that you have to show 3 significant figures, you have to use decimal point. The 653 is a good, but better 653 dot point. Yes? What like you see what? No, my answer is a 754, and you see point. Just in case you have to put point. Yeah?
Okay.
Okay, Sam, no, what? This not correct.
So how do you calculate this one?
Okay, how to calculate this one?
Yes.
Just we have to find tension.
Tension?
Yeah, no, we have to find tension of this what string. Yes. What we know? We know mass, we know gravity, and we know angle. Okay, so let's see what force acting down is a weight.
Mg.
What is a mg? Yes, mg.
Yes.
What
mg.
force acting up is a component of tensions, vertical component. So
Or mg cos theta.
what now? What what tension times sine angle theta times sine theta is a component of tension with acting up.
So
Be-
you said
because,
mg sine theta?
what? So because we have on the right and the left two tension acting. So we have what equation will be look like 2 tension, то есть 2t times sine theta equal mg. Okay, now I will take something to write you. One moment. Maybe.
Professor, I think I tried that mg sine theta, but it was impossible.
So equation look like 2t sine theta equal mg.
Oh, 2g sine theta equal to mg. 2g
Yeah,
sine theta equal to mg, right?
mg. Yes, and from this you already can find t. То есть t equal mg divided by 2 sine theta.
So at first I have to find the theta, right?
You have to find TL. No, t doesn't matter because on the left, on the right, the same t. Okay, what? Now I will go to whiteboard.
Okay. Thank
And
you.
I can write. So what? mg acting down, yes?
Yes.
What acting up? 2, because we have 2 groups on the right and to the left, times tension, but tension acting to with some angle. So vertical component to find, we have to times sine theta.
Okay.
So to find t, it will be mg divided by 2 sine theta. No, I can check. Let me calculate together. So because what I go back to your problem. Okay, where's your problem? Okay, what you have data, mass, angle. Okay, it is mass and angle. We have no mass and angle. So to calculate, I go to Google search. Okay, now I will show you what I do in Google search. Google. Of course, what is this Google search? So what we know? So you have to calculate. So theta equal mg. Okay, but I remember your m. M equal 77.8 kilogram. M times 9.8 meter per second squared. Okay, mg divided by parenthesis open 2 times sine and sine
4. I believe, yeah.
4. We have to write degree, 4 degree. Parenthesis close, again close. No, and now I will try to calculate. So I click enter. Click enter. And give me answer. Okay, let's see, big number. 5465. No, I have to have 3 significant figures and maybe scientific notation. It will be 5.47 E, and my point jump 1, 2, 3 times. So E3. Okay, what is answer? 5.473 exactly. See, I found correct answer. Do you understand?
Yes.
What? And what
Yes.
you see? What I use Google Sheets, the Google search. I prefer to use Google search. I don't know what you use, but I teach you that use Google search for problem like this.
Okay.
So
Okay,
let's continue.
Okay, thank you very much. I will try it again.
No, what? No, okay, I continue because we didn't finish your answers. Okay, what is a question number? Is a question number 2? Let us will continue.
Okay.
Okay, I will
Because
change.
I believe question number 2 and 3, they are all related. If you know
Related.
number 2, you can answer number 3.
No,
If you know the equation, yeah.
No, all this related. Yes, in number 4 is from the same area, and number only 5 is different. What?
Yeah.
And I see your answer 3 not correct, 4 not correct, 5 correct, 5 correct. Only you have to write not 7, 6, and 5 you have to write 7, 6 point. It's better.
Professor, I'm not seeing your.
You don't see.
Your
Okay,
screen.
maybe I will show you my
I don't see
screen.
your screen. Yeah.
I will show you my screen. Okay, application screen. Okay, great test. Yes, it's yours. Okay, now you see, yes? What?
Yes, now I see.
То есть we finish question 2. What? See, question 3, not
Yeah.
correct. Question 4, not correct.
Mm-hmm.
Question 5. Question 5 correct, but by rules, if question about two significant figures, you have to show this not integer number, not 76. 76 dot point, put
Dot,
point.
right? Okay. No problem.
Okay. No,
That's not correct.
question 6, close, but not exactly. I don't know why. My answer was 3.2. You have 3.8. I don't know why.
Okay, I will
What you might
try again.
correctly.
I will try again.
No, no, again, with question 7, you have, I have 9.9 E5, you have 1 E6. It's a number very close to each other, but
I have
not
like 10.
exactly.
Yeah, I have 10.
The system don't accept like correct answer. You see, because it write like a red. Red is mean the system don't accept like correct.
Okay.
So you was close, but not exactly. I don't know why. Okay. No, problem 8. No, close, but not very close. Again, system don't accept like correct answer. No, I have 1.0, you have 1.4. Why? I don't know. Oh, this 9 correct, 9 correct. 10 again not correct. I don't know why.
Okay, I will
That's
try
all.
again.
This is me. If you made 9 correctly, why very simple with the same picture, only have
Yes.
1M, you have another number. I don't know. It means you know main idea how to find, but something you made wrong. Okay. Let's see what when in problem 7, system gives you 5 points from 10. It means it's a close,
Yeah, it's close.
but not exactly. So it didn't give you 10 points, but it gives you 5 points.
Okay.
Okay.
Okay, Professor. Thank you very much.
You're welcome.
Okay, I'm gonna now sign out. Thank you.
Bye bye. Okay, most I see how many students, more one student. Nesser, do you have question today? Hey, professor. Yes, I see you. What you want? I will show you. Wanted to go over lecture 14. Okay. 14. Let you go to 14. Okay, it's yours. Okay, 14. Okay, you see. So first 348, 348, correct. Second, 2, 3, 4, 6, 7. 2, 3, 4, 6, 7. Correct. 1, 5, 6. 1, 5, 6. Correct. This correct answer. 4. 5 correct answer. 6 correct. 7, no, little bit different, but maybe system will accept. 67, 3, 67, 4. Question 8. No, again, very close, maybe system will accept. 1.90, 1.89. The same question 9, very close. Question 10. 1479. 1479. Correct. No, то есть it's good. I hope it's good. Try to submit. I hope it will be 100, my guess. I don't see still, I don't see. Okay. Now lecture 12. Lecture 12, homework 1, okay. Let me go. Lecture 12, homework 1. Lecture 12, homework 1. Homework 1. Question 1, not correct. No, it look like not. Do you need explanation? Okay. No, question 2, not correct. Question 3, not correct. Question 4, not correct. Question 5, not correct. Question 6, not correct. Question 7, not correct. Question 8, not correct. Question 9, not correct. So it's only question 10, close to answer. Little bit different. So, okay, let me will explain you. For example, what? Question 1. So, this program about this question about gravity attraction force. So you know M1, M2 located distance R are attracted to each other with a force 14 Newton. Then we know something happened with the masses. One increases 2, another increases 88. A distance increases 98 times. What we have to use? We have to use next properties. That gravity force directly proportional to product and reversely proportional to product masses and reversely proportional to distance squared. By this reason, very easy to find solution. What now I will show you. This now I will go to, I copy this to go to Google search. Now I will show you what I do in Google search. Okay, I have to change this to Google search. Okay, application screen, this. Okay, so first I will paste all data. And I know that what is the previous force? What? The previous force 14 newtons. So is like initial number what I have to use, 14 newtons. Then I know that force is directly proportional to product of mass. So by this reason, after 14 newton, I do times and times how many times increases first mass? 2 times. Times how many times increases second mass? 88. Because why? Because force directly proportional to product of masses and reversely proportional to distance. So divided by, because reversely and distance increases 98 times, but distance squared is 98 squared. What's my equation? So initial force times coefficients, coefficient of masses, 2 and 88, times divide coefficient for distance, but divide and square it. So I click enter and have answer 0.256. No, in which notation I have to submit? If scientific notation, it have to be 2.57 E1 because it jumped decimal point to right. No, not E minus 1, because jump to right 1 times. That's 2.57 E minus 1. What have to be answered? Exactly 2.57 E minus 1. Do you understand? Okay. So what use the same idea? What? This idea about proportionality. This force, gravity, attraction force proportional to product of mass. So you have to use coefficient between masses, before masses, product, and reversely proportional means you have to divide coefficient between distance, but square it. Okay. No, if you want, I will explain you some another problem. Okay, we'll try again. Thank you. You're welcome. Yeah. Have a good night. Thank you very much, Nesser. Have a good night too. Okay. No, goodbye. No more student.